Good day, everyone. Welcome to OSMART Tutor, where chemistry is made easy for every student. Today we are looking at macromolecules. Macromolecules they are a large, compound. They are large molecules made by covalent bond. And today we'll be considering two major examples. Actually, we have three that I want to talk about, but we want to talk about the first two today. We have the diamond, the graphite, and the silicon 4 oxide. So, but today we'll be looking at the first two, if time permits. So, follow us as we go in the video. Enjoy the video. Now, we have macromolecules. Macromolecules. So macromolecules, they are molecules that contain more than one, covalent bond, joining them together. So an example, a typical example of macromolecule is diamond and it's also found in graphite. So let's look at diamond structure. Diamond form a giant macromolecule. Diamond form what? A very giant, structure. And here we go. This is the structure of diamond. As you can see, in diamond, each carbon atom is connected with 4. That means all the 4 valence electrons of carbon in diamond, they are all connected together by covalent bond. And this makes diamond very, very strong. Why? Because there's no vacant electron, there's no electron that is not used. All the 4 valence electrons of carbon have been used to form covalent bond. They have been covalently bonded together, forming a very strong giant structure. And that is why diamond is the hardest substance on earth. Diamond is the hardest substance because of the fact that all the 4 electrons in carbon have been used to form bond together. So there's no free electron. Now, these particular properties have a serious effect on that. And let's talk about the implication of all the 4 electrons joined together. One, because of that, diamond cannot and does not conduct electricity. Because there is no free mobile electron there, so it cannot conduct electricity. 2, because there is no free mobile electron, diamond is now said to be very, very hard. There is nothing free, it is so hard such that nothing can cut diamond except diamond itself. So let's count. This ball represents the electrons, each atom of carbon. So if you pick this particular one, it is surrounded by 1, 2, 3, and 4. If you pick this one, you have 1, 2, 3, and 4. If you pick this one, you have 1, 2, 3, and 4. So the structure continues like that. This does a small unit from the giant structure of diamond. Now, what are the uses of diamond? What is the implication of all these properties? One, like I said, because of this hardness, diamond is used to make drilling bits. For making what? Drilling bits. You want to blast rock or very strong, maybe a particular rock or dig a very big hole in the ground, making a very industrial borehole. The drilling bit of the machine is made of diamond. 2, it is used in making abrasive. Abrasives are generally used to sharpen metals. Okay, so because of the hardness of diamond, it is used to make abrasive, like the sandpaper that you know we're familiar with. So it is used to make a abrasive. Okay, then another thing is this: diamond has a very high refractive index. Because of that property, diamond is used as jewelry. It's used in making jewelry. You can see many people like most women or young ladies like buying diamonds, all those diamond jewelries because it's very, 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 very fanciful in nature. It's very good. So it's not only for fashion alone, but it has industrial use as you can all see. Then it's also used for making all those cutting machine, the cutting tools, or making a cutting tools blade, cutting tools. We can use that one to cut glass, for cutting glass. These are just a few examples of the use of a diamond. So, like I said today, we're looking at what our focus today is the fact that diamond form a giant, molecular structure. It form what? A giant covalent structure. So this is diamond, and so you must get to know this structure. This is just a small unit out of the giant structure of a diamond. Now, the next one we're going to consider is graphite. Graphite is another form of carbon. Please, let's not forget, diamond and graphite, they are allotrope of a carbon. In fact, they are called crystalline allotrope of a carbon. So, the second allotrope is a graphite. Graphite is also a crystalline allotrope of carbon. Also, in graphite, we see that graphite forms a giant lattice, giant covalent lattice structure. And so in this case, its own is layer lattice. Now, let's go about the structure of graphite. We can draw it this way. Here we have so this is just a layer. It's just a layer of graphite. So I have this. So this is a layer of graphite. Now, this one can project downward. This is the structure of graphite. In graphite forms a layer lattice structure. Now, one thing is unique about graphite. In graphite, only three electrons are used to form covalent bond in graphite, while the remaining electron, that one electron, is left vacant between the what? The lattice to move about, and this one make it possible for graphite to conduct electricity because of the presence of mobile electrons. Now, what is the implication of the layer structure of graphite? The layer structure of graphite make it possible for graphite to be slippery, and because it is slippery, it is used, as lubricant, and also it is very, very soft. It is not as hard as carbon, and due to its softness, it can be used to make lead pencil to mark paper. So we talk of making lead pencil to make pencil, that's for marking paper. Also, is used as conductor and electrodes. Then as lubricant, lubricant in engines where ordinary temperature will melt at ordinary oil. So graphite will not melt at very high temperature. So it can withstand high temperature. So that is implication of the structure of a graphite. These are the implications of graphite. Now let's look at it more critically. Now I need to say something before I end this video. The bond between the molecules is very, very strong. As the bond between this particular atom and this one is very, very strong. Now, whereas the bond that is in the intermolecular bond, so this intermolecular bond is very soft. This is weak force. This is a weak force. Then there is a strong force there. This is very strong bond here, and with stronger molecular force. But this is a very weak bond. It's a very, very weak force. So the bond between each of the atoms are very, very strong, whereas the bond between the molecules, as intermolecular bond, is very, very weak. So this is why graphite, it is different and unique and has uses different from diamond, despite the fact that they are both from the same element. Now, if you have any questions as touching this video, please at the comment section post your question there, and I will gladly welcome and reply your question appropriately. Please, thank you for watching. Do subscribe to this channel. Don't forget to press the like button and share with your friend. Thank you.